Please welcome SSA Policy Forum moderator Andrew Duva to the stage.
Okay, I'd also like to ask my panelists to come up so we can respect your time. Aloha, and it is an absolute pleasure to be here. Thank you to the Maui Economic Development Board and Secure World Foundation for organizing the SSA Policy Forum, and thanks to our VIPs here, Paul Kervin, General James, General Shelton, General Shaw, and General James, Director Maury, Kevin O'Connell, Doug Lavero. It is a very interesting time to be here. And what we're going to try to do for you is to answer General Shaw's challenge about what things might look like in the future. But I can't give you 220 years in the future. We'll try to do our best. Before we get started, say it's good to open with a joke. So a horse walks into a bar, and the bartender asks the horse, "Is there anything I can get you?" And the horse says, "I think not," and promptly disappears. If you didn't get the joke, it's really about the French philosopher Descartes, right? And he said, I think, therefore I am. So if the horse says, "I think not," he has to disappear. But if I'd explained the joke that way, I would have been putting Descartes before the horse. And, But that's exactly, thank you, that's exactly what we're going to try to do here. So get ready for some magic. Is everybody ready? Okay, in a few seconds, you're going to be transported 10 years into the future. The great news is this technology is painless. You might not feel anything except a little bit of anticipation, but 3, 2, 1, it is now 2029. 10 years on, we are celebrating the 30th anniversary of the AMOS conference and the 10th anniversary of today's launched Space Safety Coalition. I urge everyone to go to spacesafety.org to learn more about the 22 organizations that you can join. By 2029, there'll be a lot more, but as of 2019, when it was started, it was a quarter of the GEOs, quarter of the LEOs, lots and lots of organizations dedicated to endorsing space safety and best practices. So check that out, because that's going to have been a success story. But the other success story is that we will have a civil and commercial STM system in 2029. What could it look like? Well, we know it's going to cover launch operations, on-orbit operations, re-entry, and deorbit. And it's going to be of some degree of effectiveness. Will it be a federated system? It sounds like it, possibly based on the activities we heard of from Director Maury. Japan's building systems and capabilities, as are others. It may become monolithic. We don't know. It'll probably make use of machine-to-machine interfaces. The regulatory environment, will it be permissive or prescriptive? Don't know. How will we handle bad actors? Will it cover cislunar activities? What will our norms and regulations look like at that time? I don't have any answers. Fortunately, these folks do. And I want to introduce them, and then the way this will work is each of them will provide their perspectives from 2029 about the problems that we solved, what's working, what we still have to do as of 2029, and how we got there. And I hope that that will provide a framework for all of you as we go forward in the conference to think about the challenges that you were working on back in 2019 and how you solved those and what remains. So, without further, and then the important part is we're not going to take all your time. We want to be challenged ask questions. This is a participatory exercise, and the way that will work, I think we'll put it up after the initial remarks from the panelists. But there's a site that you can get to from your AMOS app, or go to bit.ly on your web browser and put in the code AMOS19, all caps, AMOS 19, and you can send your questions in, and I'll moderate the questions for the panel just to keep things organized. So here today, I want to introduce our panelists from your left to your right. We have Dr. T.S. Kelso from the Center for Space Standards and Innovation at AGI, and also has been running the Space Data Center operations. Steph Earle from the Federal Aviation Administration, who is the STM program lead. Walt Everett, who is from Iridium and is responsible for the space and ground operations and development. And Wasanchai Vongsantivanic, did I do okay? From the Thailand's Geoinformatics and Space Technology Development Agency, just TDA, where he's a manager working in the SSA area. So with that, I will get off the stage, and I think I'll turn it over to TS, and we'll go down the table for statements, and then we'll get into the Q&A. Thanks.
Thanks, Andrew. And I want to say mahalo to the AMOS organizers for providing me this wonderful opportunity to share a look back from 2029 on how we developed what is now a successful and thriving space traffic management environment. And I'll say that I'm happy to share my prepared remarks that have been approved by the Time Council. And so we'll get started. And we've certainly come a long way. At the turn of the 21st century, people actually thought we didn't need to worry about space traffic management because space is a big place. And satellite operators often thought that the only reason they ever received a warning was because it was a big space. And that wasn't because nobody was actually looking. Back then, nobody actually tried to do CA other than DoD, and they did that only for DoD satellites because they believed it would take a supercomputer, millions of dollars, and couldn't be done in a timely fashion. It didn't. The community started by showing it could be done for all satellites in under an hour on a basic PC and then made available via machine-to-machine interactions on the internet. That was done using something called TLEs. I don't know if any of you guys remember those, which, while good for their originally intended purpose of maintaining track custody, weren't really suitable for CA or conjunction assessment. We realized that the hardest satellites to track, the operational ones that maneuvered regularly, had operators that were willing to share their ephemerides and maneuvers. That started in 2008 with pioneers like Intelsat, Inmarsat, SES, and Telesat, doing something that in 2019 you might consider to be called crowdsourcing. We realized that space traffic management, unlike air traffic control, is not geographically limited, in that any accidents would affect the global space commons. That meant that space traffic management was an international issue, and an international organization was formed to manage data collection, quality control, analysis, and reporting. Satellite operators realized that space traffic management was truly a collaborative effort, and that individual operators or countries could not go it alone. Launch providers, on behalf of their launching states, began requiring proof of CA services as part of their launch certification process. Initially, we were constrained by trying to get better data, with commercial providers struggling to compete with SSA capabilities developed by DoD because these were perceived to be free. Of course, they were not free, costing the taxpayers billions, the US taxpayers, billions of dollars each year. And US military organizations, or anyone's military organizations, could not provide the transparency required for CA due to the nature of their missions. So we found that commercial systems were much more agile in adopting new technology and mass producing it to collect SSA that was accurate, persistent, and timely. And we recognized that commercial systems, even though they were much less expensive, needed to be paid for too. We eventually did this via global SSA co-op or marketplace, which allowed providers to focus on providing the best data available. We realized the value of comparing results from diverse systems as part of an ongoing quality control process to find inevitable problems in any system, and this was greatly facilitated by the use of artificial intelligence. As satellites proliferated, operators realized the need to develop low-cost passive tracking systems for all objects sent to space, including rocket bodies, to ensure that tracking networks could quickly identify and track them under all conditions. As a community, we realized that leaving satellites and launch debris in orbit for 25 years or longer was irresponsible and adopted a more responsible pack-it-in, pack-it-out environmental perspective. We recognized that while distance was an easy-to-understand metric, that we needed to handle uncertainty and, more importantly, use risk in our decision-making. We realized that probability of collision was not sufficient when comparing the chance of being hit by a 1 centimeter piece of debris or getting hit by an object the size of a school bus. We came to understand that accepting risk of minor collisions, which might damage or even kill a single satellite, was up to that satellite's operator, but that standards for avoiding catastrophic collisions which would harm the overall space environment were an international decision. We worked to establish norms for generating and exchanging covariance data, for orbits and maneuvers, even for launch. We realized that sharing data on location, size, and mass of satellites was no different than what we did to handle our driverless vehicles on the land, in sea, and space, or in air, and worked together to collect that data. We changed the overall ops tempo of batch runs for CA to a continuous process of updating results as new data became available, and quantum computing made that easy. We started openly sharing CA results with all operators in a collaborative fashion to ensure everyone had a common operating picture and could review all the quality control data as well. And AI and quantum computing made assessing collision avoidance maneuvers substantially easier than back in the early days. And finally, we mastered privacy, authentication, and data exchange standards to ensure this vital data was protected and users were confident as to its pedigree using tools like blockchain. And concepts like what we used to call augmented reality, combined with machine learning that anticipated what analysts wanted to see, made interacting with complex data systems intuitive and greatly facilitated helping decision makers understand their courses of action, especially in exceptional cases. So don't think that just because the ending is going to be good, that there isn't a lot of work for you to do out there. That's going to take global collaboration, transparency, and I'm confident that many of you in the audience today are prepared to work together and lead that effort. Thank you.
Thanks, TS. That's a lot for us to think about. Over to you, Steph.
Well, mahalo for inviting me again into my Maui ohana. Thank you for bringing me back. I will apologize right off the bat that futurist is not on my resume. And I hope, since it's 2029, that I don't need my resume again. So caveat that my comments are probably a little harder coming from a federal agency. And when you predict the future to 2029, it's pretty easy if you have a glide path that you know you're going to stick to. But I think ours is a little bit variable. So I'll give it a try, and we'll see how it goes. So if it's 2029, I'll say the Department of Transportation continues its mission of safety and efficiency in all modes of transportation. So you got here in your connected vehicle, and so you remember back in the days of 2019, you had a little light in your more modern vehicle that told you there was a car next to you, you shouldn't pull out. And now you have a light that tells you there's a car around the bend, and you shouldn't pass. All of those blind spots have been solved. So connected vehicles will have been a thing of the past, or a thing of the future now. Next gen will be fully implemented, so aviation will be more efficient, and it is more effective. We fly places in shorter time, we save more fuel, we impact the environment less. All of that is done. UAVs are fully integrated into the national airspace, common, and we've seen all kinds of new commercial activities with those. Commercial space transportation has continued to grow. And it itself, we've seen over the last decade new proposals. Reusability, which started before 2019, is more common. More operators are going to be using or are continuing to use reusability. We've seen the second stage reusability, a task that it's pretty much driven by the same needs for the first stage, and so that is contributing to a more cost-effective launch profile as well as limiting orbital debris and bringing that down, making space safer. We've seen more space tourism in both suborbital and other adventures as those progress forward. And it's more broader than simply a few places in the United States. We expect to see or have seen an expansion of use of spaceports throughout and more of a balanced. Today we see, or in 2019, I should say, we saw that there were just pockets where a lot of space activity is. What we've seen over the last decade then is more of a balancing of that. Suborbital activities need to be over here because it's more efficient, orbital launch vehicles over here because it's more efficient, and a blend that we balance out once we reach a nominal transportation need. We'll continue on with launch opportunities have become more prevalent and more cost-effective. The number of launch operators, active launch operators, dramatically increased over the years, considering the FAA was reviewing over 50 or 30 proposals at any given time. Not everyone has made it, but a large number, significantly changing the transportation forecast. So if you're an operator, satellites still can't get to orbit on their own. No satellite has enough propulsion to make that journey. They have to stand on the shoulders of some launch vehicle, and that continues. So we'll see have seen a new level of space activity. And just like with every other mode of transportation, how does that mode interact with all the other modes has been leveled out a little bit more, and we have a little bit better understanding of how all of the transportation needs go. So just like you drive your car across a railway crossing, or you drive your car over a drawbridge, and you see those are two modes of transportation, we pretty much hammered out the aviation and the launch interaction so that both of those can be profitable and efficient and effective. In addition, I will say that for orbital safety, or for launch and reentry safety, thanks to the efforts of just one small engineer in the Department of Transportation, we've moved forward, and and what we're looking for is, thanks to industry's development over the last 10 years, new ways of evaluating the risks of entering a very complex space environment for launch vehicles, because that's a niche that has to be solved, and industry is the best place to solve that. I think those would be the large takeaways I have for the launch and reentry and the transportation viewpoints of 2029.
Thank you, Steve. Okay, just a reminder that you can ask questions when they're getting queued up at the Siftly site. Maybe we can put that up there. You can they're being queued. I've got a great list but I want to get the whole panel going.
We're ready.
So they're going to be ready. Please keep the questions coming, and some good ones already. Next, I'd like to turn it over to Walt Everett.
Thank you. So I want to go back to something that the chaplain said a little while ago. He referenced, what is your mountain, what is your river, and how did we get here? My mountain is Everest. I did Mount Everest in 2012. It was exciting, it was a wonderful time, and it took me as close to the stars as I'll ever get. My river was the Ohio River. I worked every weekend, every holiday, every summer to put myself through university. And how did I get here? February 2009. As everybody in this room probably knows, in February of 2009, there was an event that occurred that really changed the paradigm of SSA. I think it was about 11 o'clock in the morning local time. I was living in Phoenix. And by 3 o'clock, I spoke to T.S. Kelso and said, what do we do? I think about that same time, General Shelton, you were reached out by General Campbell at the same time, trying to understand the big picture of what this all means means to industry, to government, to the future. I want to thank everybody for being here. I think it was great, and I appreciate, Andrew, you reaching out and asking me to be here. I'm going to digress just a bit. We just finished the largest constellation refresh the world has ever known, Iridium Next, and we also deorbited all of our original Block 1 satellites, but one. We still have one more this year. That's responsible behavior in space. We did it in cooperation with government, industry, the FAA, the Commerce Department. There was no shortage of people willing to help and people that we looked to for help. It was an exciting time. It is an exciting time. My solution to that is surround yourself with really, really smart people and let them do what they do best. As I told TS earlier, I'm just the eye candy for Iridium. The smart people are back there making this all happen. That's not funny. So understanding where we are today and then trying to take that to 2029. So today, Iridium, and I can speak for many, many owner-operators on the commercial side and the government side and the civil side, we're very transparent. We make sure that anything that we are doing is transparent to every other owner-operator out there. We make sure that we communicate as much as we can. We share best practices. We do all of the things that will help space because we are just one of many people populating space. And certainly that risk that we all accept and that risk that we all make affects the rest of the owner-operators in this world. We try to be as extremely responsible as we can. You know, I have 4 or 5 people that are dedicated just to SSA, and their key tenet is be responsible. That's how we deorbit. That's how we miss vehicles. That's how we, do slot swaps. That's how we coordinate with our regulatory brethren. And then I want to start thinking about where we want to be in the future. I will not be here. I am retired. 5 years from now, I'm done. But I still have a vested interest in making sure that that the world's economy can continue to grow and prosper, and part of that is because of the space industry that we're all part of. So where will we be in 2029? I mean, that's the question that we're being asked. If we magically put ourselves in 10 years forward, it's really hard to understand because 10 years ago, we didn't realize where we would be today. I think increased transparency is key. Share your data. If there's somebody that wants your data, share the data. If there's somebody that wants to reach out to you and talk to you about space situational awareness, invite them together. Invite them in. Talk to them. Learn from them. Share with them. There is no such thing as keeping it close to the vest because it doesn't help anybody. I think it's important that we all understand that this isn't impossible. It sounds hard, and there's certainly no shortage of alarmists in this world that says that it's impossible to do SSA with, in my case, 76 satellites, in other cases, hundreds of satellites or thousands of satellites. It's not impossible. It's hard. It takes an effort, but it's not something that can't be done, and we need to do it. We need to be, again, as forthright as we can with everybody. I think you used the term a moment ago, pack it in, pack it out. My term is leave no trace. I'm an avid camper, I'm an avid hiker, and part of what I do is leave no trace out there. That's a key part of what we all have to think about is in 2029, it's not just about what you're launching and what your mission does, but also your post-mission disposal, your depressurization, all of the things that you need to do to maintain that safe environment, that clean environment, because I really hate seeing trash in the trail. I'm really upset seeing bad behavior in space. And I guess finally, just to talk a little bit about policy and policing. That seems to come up a lot. I think we self-govern ourselves fairly well. I don't know if the right thing to do is to set forth policy and dictate policy for all of us to adhere to. I guess I'm personally in the name and shame game. I want to make sure that we establish the best practices that we can out there. Promote the best practices that we all can. I'm not sure where we're going to stand in the policy and the policing part of it, but I think it's something that we're all going to have to face between now and 2029. I think it's part of what we're dealing with now and part of what we're going to be doing in the near and the long-term future. So, with that in mind, I'll be retired in 2029, I hope. But I still have a vested interest in how we get there. So, again, thank you very much for the time. I hope I helped. Thanks.
Thank you all. Okay. Watson Chai?
Okay, thank you very much. It's an honor for me to be here with 4 big names here. And obviously, I think you guys might have a questions why Thailand sitting here on the table. I think, and it's very difficult for me as well because, all the issues has been discussed by, I'm the last presenter, so everything has been said, like STM about the launch and about the transparency. So for me, I try to talk about from the different point of view. As you can see, I have the longest name here. I come from non-US countries, another side of the world. And the second point that I would like to represent is I'm from Thailand. We are emerging space country, space newcomer. So what do we think about space in 2029? The third thing I can say is about Thailand. We can be the examples of the victim of the unsafe use of space. I will tell you the reason why. And the last thing you can see as I'm the youngest one here. I will work, I think, after 2029, so I will. So lastly, I will have some comments on this and how could we do about this. So the first thing for Thailand, of course, some of you might not know, we have satellite, we operate satellites, we understand a bit of CA, thanks to JSPOC and soon CSPOC. And a few years ago, we start to we have telescope. It's very easy to have one these days. We have 0.4, 0.5. We try to point to the slots, and of course we see a lot of uncatalogued objects. And this starts our SSA activities in Thailand. So me with my senior colleagues, as you can see around Group Captain Thagun, we start slowly our SSA, and he participated AMOS, I think 4 consecutive years already. We learned a lot from this community. So thank you. So on top of that, another problem that we have in this recent 2 years is about Thailand as a victim of unsafe use of space. We have a big country neighbor on the north of us, China. You might know. They have a lot of launch facility, as you know it, and of course in US you want do the polar orbit launch from the launch site. You want put the launch site in Montana to do the polar orbit launch. But we have some re-entry debris from those launch, and it's happened more frequent. This is what I can say. And this is now we're talking about big constellations in US and everywhere in Europe, the companies everywhere around the world. You're talking about LEO constellation of hundreds or thousands of satellites. And from what I see in every conference, these numbers come from only the companies from the West. But of course, in China, the launch cost is also competitive, if you know it. It might be very competitive for foreign companies, but for internal Chinese company is very competitive. I know that. So those big constellations from the East is not yet taken into account. So I think this is one point that we should bring into concern. And as of now, the launch is not that much, but already we have some launch debris from falling into our territory, and not only us. I just have a quick chat with my friends from Philippines. They also have some debris, and like normally everyone says that if you got hit by the debris from space, you are very lucky. The chance is like slimmer than you win the lottery 2 consecutive times, right? But in Thailand, we are very lucky. I don't have a PowerPoint here because, like, you know, this session is quite short. I can show you later the pictures of, like, you know, the hole in the roof of the school and the temples. We have that case, and it happens like once every 2 months, something like that. And soon, if you think about like bigger constellation, this might be the problem, very big one. Okay. And another point that I would like to try to point out is like, of course, here everyone is like, you know, you are currently working in the space industry, and you are very well aware of the space traffic, the congestion in low Earth orbit and in every orbit, right? But the important thing is not the people inside this room. I think it's about the people outside the room, about the public. Of course, to do the like control re-entry or like, you know, STM will cost more in the future and for the space operation. And the one who bear this cost is not only, you know, space industry. It will be the government. It will be the public user. So I think it's not only space people that we should not like build the awareness of this kind of thing only for space people. We should like build the awareness of this kind of thing for the public as well. And I can give you some example of what we are doing in Thailand. Of course, like for this room, CubeSat is nothing. You see students do CubeSat and like you ask them why you are making new space debris. But if you look into kids, this is their life, right? In emerging space country, like if we have like 3 high schools now in Thailand that trying to develop their own CubeSats. And if like any engineers or like, you know, you guys from big companies go to them, you said, oh, don't do this, you create more space debris. But for them, it's the first time. So how do you deal with this? I think this is another interesting issue that we should think about. And for me, luckily, I'm one of the advisors for one of those schools. And what I try to do is like, at the same time we teach them to make satellite, to build satellite, we give them also the space telescope and teach them to point out to the satellites to see how crowded it is and like the catalog object, uncatalog object. Of course, it's very easy this day for everyone to see uncatalog objects. Even the high school student in Thailand, we do that. I can show you a lot of pictures of students doing SSA. Maybe they just like see the dots in the camera, but in the telescope. But of course, we have to teach them more. But at least they are aware of the SSA and STM. And I think these students, the kids in the school, they are the future of our space community. So I think this is very important also. So thank you very much. That's all my points here.
Okay, those were some great perspectives and ideas about how it's going to be in the future and how we got there. And I have to compliment the audience because we've got a ton of great questions. Let's start with an easy one. To what extent will SSA and response systems operate without a human in the loop? Walt?
I don't think they can. I think it's a fair question. I recognize that that a lot of machine learning is key to the future. And I recognize that the more we can automate, the better off we're all going to be. I mean, we have the largest constellation of satellites that orbit the planet Earth, and we have to automate everything that we do, but we have a human in the loop. We have a brain cell that is out there saying yes or no based upon less intrinsic pieces of data. How big is the debris object? You know, what's the probability the last time they were tracked? I mean, there's lots of things that you can do, but you really do need a human in the loop somewhere. We do it all the time. You know, we have to automate everything that we do, but the last step in that is a human. So I don't think you can.
Other perspectives? Okay, easy enough. Well, let me ask a follow-up then. Back in 2019, there was a case where at that time, new satellite operator, LEO operator, was in an orbit that was nearby to a space agency, satellite operated by a space agency. And there was a well-reported case where communications between humans didn't really happen. There was a reliance on automation, maybe a too large a reliance back in 2019. And the question becomes, in cases like that, I can't remember what happened, maybe my panel remembers, who should move in case of two controlled objects? What's the calculus for that?
All right, well, I won't comment on the 2019.
Can't remember how that turned out.
No, but I will say, so generally, this is an area where in all of recorded history and transportation, eventually, it always works out. It doesn't work out the same. You can't drive on the right in every country. You can't drive on the left in every country. It's always different. But what happens is somehow we develop a common goal, a common need, and we decide what we're going to do based on that. So, I mean, obviously, why is the risk, while there are still risks in GEO, why is it not equal to the risks in LEO? Is because basically everything goes the same way, for the most part. So your risks are different there. I think that the question of who moves over time will hammer itself out. We've seen this in all modes of transportation. Today, if I had to say what you would do, I guess number one, you say, first off, who can move? Obviously, we're only talking a small percentage of the objects on orbit have the ability to move. There's no requirement to have propulsion or the ability to move. So that's another issue there. But first, you have to say who can move. In this case, if you have two systems that both have the capacity to move, I think you let them first work amongst themselves. And we found that works best is first to do that. So when we're at a GEO, if somebody's intended to move already, then that's the most efficient use. So is there a way to mandate who moves without considering that efficiency? I don't think we're there yet. In aviation, we have the ability to move a lot of things because we have designed into aviation a flexibility and variability that allows us to control that. That does not exist on orbit. We just don't have that designed-in flexibility. So that's a long answer to a short question that I tried to avoid.
You did so well. Thank you.
Andrew, I want to add a few things. I want to give some real-world experience here. I don't think you can, I absolutely agree with everything you just said. I don't think you can mandate the person on the left moves or the older constellation moves. It's impossible. Again, it's reliant upon people in the loop. And I'll give a real example. Our orbital shell is shared with another owner-operator. Most of our conjunctions, I think it's 98.3% of our conjunctions, are with non-maneuverable debris. So it's pretty simple, we move. There is another owner-operator we have a great relationship with. We speak to them daily, weekly, whenever is necessary. And the interesting thing is that in the beginning, when we started getting CDMs and information from CSPOC, we reached out, and it's Orbcomm, it's known, but we reached out to Orbcomm, and most of the time, Orbcomm moved. And that's because they had the capability of doing a retro thruster. We did not. That has changed now that we have Next out there because we have the ability to actually move in two different, easily move. We could do it before, but It's a lot easier to do it today, so most of the time we move. But what we do is we cooperate. We are transparent, we call them, we make a phone call, we have 24-hour coverage, we do what is necessary to make sure that we're not both doing the same thing and causing a problem.
Okay, that's interesting, because you mentioned that you've got 24/7 coverage.
Yeah.
You had it back in 2019, still have it today in 2029.
It will happen all the time.
Yeah, so should different rules apply for developed, mature space operators such as Iridium versus perhaps a high school CubeSat project? Who's manning or staffing their satellite operations 24/7, or should they not, does it not apply?
Again, it's a very fair question, and it does happen. I mean, it doesn't happen very often because most of ours is debris, but in that case, we would go ahead and maneuver. We would make the decision. We couldn't get a hold of the other owner-operator. We tried. Of course, we have 7-day look-ahead, so it's pretty impossible that we would not know or be able to contact that person, that other CubeSat, that academic institution. And if we could not, we would go ahead and maneuver. We would make the decision that that other conjunctor was not moving. It's a good question, though.
Let's build on, oh, go ahead, yes.
I'll just add one thing from my prepared remarks, my approved remarks, that when we talked about the launch providers finally getting to the point where they required proof of CA services, that was exactly why that happened, was because you had, valid educational, amateur, commercial systems that were going up that in 2019, some of them were not well prepared to handle those kinds of situations, and it did become a problem. And we decided that we needed to have a way to ensure that they were prepared for those eventualities and how to work with the rest of the community when those kinds of events did occur.
So the practice evolved to require essentially operators to subscribe or participate in this STM system. What other hardware and ConOps requirements do the panel think will have been implemented in 2029 to enhance safety? For example, beacons, TCAS-like systems, other ConOps. Take that one, I guess.
Go ahead,
Go ahead.
please.
Yeah, that was, if I remember my history right, 2019, we were having considerable problems in that area. And again, with some of these new, let's say, agents coming into the satellite environment, so particularly educational. And we found that they were trying to be small and be inexpensive, but at the same time, it was presenting a risk to the rest of the environment. And actually, the commercial providers got together and decided that, the best way to do that was to come up with some kind of a passive system that was easy to put on, anything from a CubeSat to a rocket body, to help the guys that are actually doing SSA to track those unambiguously. So not only know where they are, but what they are. And that made a tremendous difference in what we were able to do in that environment to make sure that these guys could actually find their satellite and work with it after they'd gone through all the effort to build and launch it.
Matthias, in your prepared remarks, you mentioned that we have moved to a risk-based approach, risk management approach. So does that suggest that for satellites of a certain mass, that there has also evolved to be a requirement that they be maneuverable in some way?
Yeah, actually, not sure why they didn't approve me saying that. Those time council guys, I don't know about them sometimes. But yeah, there was actually a requirement that there be some kind of maneuverability capability on systems. And so today, I think, in 2019, where you were, that was not really feasible. But eventually, we got to the point where it's, if you're going to put something up, you've got to be able to control that asset, not just toss it up in orbit and hope for the best.
I have something to add here for this question and for the previous question as well. This may be some point you have never think about. It's a fun story. So like 10 years ago when we just had satellite and begin the satellite operations in Thailand from the government agency, every time those operators got email from JSPOC, they are very exciting about the message. So, so they tend to move most of the time, like, oh, we should move. Even the POC is quite low. But yeah, for flying planes, for pilots, you need license, right? But for moving satellite, for maneuvering, you don't need any license. Any universities, satellites, small satellites with propulsion payload, you can move. But how you make sure that those move will not create more risk? I think this is another point that we should think about.
Well, Steph, let me ask you, are there licensing requirements that evolve for launch or re-entry activities from the FAA's perspective? Are there now qualified
over the
operators?
next 10 years?
Yeah, over the next 10 years.
All right, so the question here is the classic question in transportation. When do you take the bikes off of the highway?
Yep.
Because they can't keep up with the pace and it's not safe. And so that's the same question we're asking now about these systems. And we have different ways of categorizing. Obviously, bicycles are different than motorcycles, and we do let motorcycles onto the highways, even though they're smaller than cars. And so when we talk about satellites and we start talking about mass, are we talking about small vehicles that have the capacity to do what they're supposed to do? Or are we talking about small vehicles that are almost amateur in their approach, novel or limited, but still useful? So that's the question that I think is here. I don't know in the next 10 years or the last 10 years, what was the tipping point or will be the tipping point to move us over that line. But I could argue that history shows that we've always moved over that line. And that these questions that were asked 10 years ago at this conference are the same questions that were asked in all other modes, and we've somehow moved over that line. So I don't know where the tipping point is on that. There's definitely a cry. There's definitely a need. The question is also, when does that need exceed the cost? Because there's an opportunity cost, and there's an actual operational cost. And so while we're talking about the one side of this, some of the safety side, but we also have to bring in the efficiency and what's it going to cost to do those things. So I will not prognosticate about whether or not the regulation changed within the next 10 years to include those. I will say that eventually, maybe 10, maybe 20 years, then it seems like it's inevitable that regulations will have changed to make that happen.
Okay. You mentioned cost. A lot of the audience has also asked, who's paying for this STM of 2029? How is this ecosystem sustainable? Easy one. Anyone?
Nope.
Oh, gosh. All right. So space traffic management costs. Yes. So we have evaluated traffic management in other regimes. We have a highway regime that gathers its funding from different methods, and we have a railway and a maritime and an aviation. Space is unique amongst our transportation modes is that we don't collect fees from our space community and then use those and turn those around. So it's unique in that. So are we talking about funding? I think this is one where it's going to be a little bit of blend between the government and commercial. Because we do see a lot of utility in the commercial avenues that can provide space traffic management services and assistances at a cost above what you would normally get. So let's just say, let's be honest right now, the Department of Defense has borne the cost up until this point. Purely borne the cost and paid for it. It has been a secondary mission, but it's been no less a priority at the same time. So as we move, according to the presidential directives, to a civil agency, and we move that question is, does that civil agency get congressional funding to build up and do that? And I think that in today's world, there's definitely partnerships that are required. There's definitely avenues to look at what part of this is intrinsically governmental that we have to do, we have to provide. I think that if you're a satellite operator, you're already looking for commercial applications that can help you be better and be safer. So I think that we are not going to look for that way. So the cost it's a difficult task, it's a difficult area. The policies that we have today are moving it to a civil agency. The cost will start there. I think it's going to be funded, a basic there, and then we'll see a lot of industry and a lot of movement forward on that.
Yeah, again, I couldn't agree more. I mean, I don't know where we're going to be.
Can you write my next performance report?
Yes, I can. It's hard to tell. I mean, I know Space Policy Directive 3 was very succinct in what they instructed Commerce Department to take over that entity. And, you know, again, I agree that, you know, the burden was placed on the DoD, the U.S. government, to do this, and I think we'll transition over. Cost is going to be a tricky subject. Again, in all honesty, I don't know where it's going to go. In 2029, I think even Space Policy Directive 3 said, you know, you need to absorb information from all commercial partners as well. I mean, there's a lot of companies that are out there that are looking at SSA and having their own radars and capabilities, and I think all of that will be provided. At what cost, I don't know. I can't answer the cost question. I think in 2029 there'll be a larger repository of data in a different location than it is today. Who pays for it? Don't know.
Okay.
Another great question.
Well, we've got another class of questions. I've had at least 10 on this, various forms. And in one flavor or another, it's all about enforcement and bad actors. What happens when you have non-cooperative space operators, constellations that perhaps are commercial, and the project becomes abandoned due to financial difficulties or just non-cooperative actors? How is enforcement and positive control maintained? What should the regulatory and operational environment look? What does it look like now? Has it changed from the 2019 laissez-faire kind of, you know, if you have a satellite, you have authority to operate in space, or is it, are there space? I mean, I've got a question. Are there space cops in the future, and is it Space Command or something else?
Okay, so we have an enforcement role as a regulator. We have an enforcement division, and I will say of the commercial space launch industry that they're not bad actors on purpose. They do nothing of that kind. That doesn't mean we don't have enforcement activities, because every once in a while they make a mistake or they'll cut a corner, but I wouldn't categorize them as bad actors. I think when we start talking about bad actors, we're really talking almost on the international level, where some actor, I don't know, I won't say this entirely, but no one ever intends to go out and be the bad actor. Instead, they just have a different calculus of what their risk is and what they can accept and put up there. And so by our calculations, then we would say they're a bad actor because they put this up there, they just abandoned it in place. So they have a different calculus, and so this is where really we get into the naming and shaming that people talked about and how can we work. I guess the best way to beat this before you get to enforcement is you have to have those international standards and norms. Before you can even start talking about enforcement and identifying those bad actors, you have to have those norms of behavior that are understood before you can do that. Because we don't have the same level of control across all international actors or awareness. Some countries have satellites with no SSA capability inherent on their own. And so for us to call them bad actors because they did something when they're relying on other countries to get this information. So before I go to enforcement and bad actors, I would say first, you have to have those standards and best practices so you can really universally understand when an action is bad. This is on just the public side. Obviously, there are other activities that can go on that are of national interest that other countries can do, and then those are clearly sometimes can be bad actors. And we don't have a rep from the State Department up here, and that's who I would turn to.
Okay. I think this is going to be our last question. But to standards and practices, again, I refer to the 10th anniversary of the Space Safety Coalition, spacesafety.org. Operators are standing by, so visit now. Last question. The first major catastrophic collision inevitably occurs, as it probably will. How does the international community and operators respond? We have about 3 minutes to solve that one.
How do they respond?
Yeah, what's the response to the next, Walt, you mentioned how you came here, and when an analogous event occurs in the future, do you think that things will be the same for your those who follow you, or will we approach it differently?
So that's it's an interesting question again. I think, you know, if you look at the best practices that you were just discussing, and naming and shaming and signing up to a set of best practices, again, policy aside or policing aside, I think that's going to make space safer. I think it's unrealistic to believe that it won't happen again between now and 2029. I think whoever does that or whoever it happens to needs to take the responsible position in saying, look, we're going to, we made a mistake, or we did all of the right things, and, you know, we deorbited our satellites, or we maneuvered, and, you know, we communicated correctly. There's 1,000 things that you can do. I think it will happen. I don't know what the community at large will do based upon that. I would hope that if they're responsible, it'll be, you did all of the right things and we expect you to do all the right things. Here's some new norms of behavior that you should go forward with. If they didn't do the right things, then I think, you know, international pressure is going to be placed upon them to not do that again. It's my guess.
Okay. Well, as we draw to a close, we're going to have to use that advanced time travel technology to return you to the break at the 2019 AMOS conference. But before you go, would you please join me in thanking our panelists for exposing these problems?